Okay, page 3 then. So we're going to use our answers from number 6, that the possible zeros, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So there are 8 that could be a 0. I always try 1 first, and a lot of times I get lucky, and 1 will work. So I'm going to divide synthetically. 1, 4, -3, -6. If it works, great. Then I'll have it knocked down to a quadratic, and I can either factor it or use a quadratic formula. Okay, bring the 1 down. 1 times 1 is 1. 1 and 4 is 5. 5 times 1 is 5. -3 and 5 is 2. 2 times 1 is 2. That didn't work. It needs to turn out to be a 0 in order for it to be a 0. So that one didn't work. Darn. Okay, let's try -1. And you might say, well, why didn't you use 2 or 3? You know, it's just a guess. Usually 1 or -1 will work. Not always. Sometimes they give you a tricky one. Okay, 1 times -1 is -1. 4 and -1 is 3. 3 times -1 is -3. -3 and -3 is -6. And then -6 times -1 is 6. Yay, that one worked. Okay, so yay. Okay, that means now we have this quadratic. 1x squared plus 3x minus 6. Now, normally I would factor this, but this one doesn't factor. Darn. So you're trying to find when does this equal 0, just like you're solving a quadratic equation. And it doesn't factor, so we're going to have to use the quadratic formula. If you don't remember the quadratic formula, I'll put it up real quick. So you might want that on your page of notes in case you need it. Okay, so b is 3, so the opposite of b, plus or minus b squared minus 4 times a, which is 1, and c, which is -6. That -6 is really important. You get the signs right on those. Okay, over 2 times 1. So then I do a little bit of math. I'm going to go over here, I guess. -3 plus or minus, it's going to be 9 plus 24. Because you've got a -4 times 1 times -6, which is going to be positive 24. Okay, over 2. And then, I might run out of room, but -3 plus or minus the square root of 33 over 2. Now, here's a piece of good news. It looks kind of messy, but the good news is it doesn't simplify anymore. 33 is just 3 times 11, so you can't like break it down. There's no pairs, and anyway, it's done. It's just a number. There's no I. It's not these aren't imaginary solutions because 33 is positive. Okay, so we're ready to write our answers. The question says find all the zeros. Don't forget the 0 you found over here. Okay, so the zeros, you can just put on your answer zeros, and then you can just list them, or you can put it in set notation. -1 is a 0. -3 minus the square root of 33 over 2, that's just a real number. And then -3 plus the square root of 33 over 2. And that's it right there. Those are the zeros. Okay, that's that one. Consider the rational function. Okay, this is a rational function. We did work with those. These are a little tricky. The vertical asymptotes come from the denominator. So when does x squared plus 2x minus 24 equal 0? So we want to factor that, and hopefully it'll factor. It does. X plus 6 and x minus 4. How that factors. Now, this creates this interesting situation then. So you have x plus 6 over x plus 6 times x minus 4. Well, guess what? That x plus 6 and that x plus 6 cancel. And so we get the function to be f of x actually equaling 1 over x minus 4. Now, you might say, well, what about that x plus 6? We'll talk about that in a minute. It won't be an asymptote. The only vertical asymptote we're going to get is from here. And so we're going to say for the vertical asymptotes, that's part A here. I just usually abbreviate it. Right? You're supposed to write it as an equation, x equals 4. So you only have one vertical asymptote. Now, you might still be saying, but what about that x plus 6? I was going to put x minus 6 as a vertical asymptote. No, because it cancels, it becomes a whole. So part B says find the point of the holes, if any. You could have more than one thing cancel, I guess. These are fairly simple rational functions, so that's probably only going to get one hole, but you could have more than one. So it says find the point of the holes, if any. So the point of the hole is going to be when x equals -6. Now it says find the point. That means an ordered pair. So how do you find the point? Well, you know it's going to happen when it's this factor that you can't have it be part of the solution because x isn't part of the denominator. So you have to take out when x equals -6. Okay, I hope that made sense. So you plug it into the function here. So you're going to say f of -6 with that reduced function. So this is actually what you would graph if you were graphing it. You'd graph 1 over x minus 4. You'd have an asymptote, a vertical asymptote at 4, and then you're going to have a hole in your graph. And it's going to happen at when x is -6. And actually this is going to be 1 over -10. So the point, the hole, the hole is at, I guess I can put at, it's an ordered pair, -6, comma, -1 over 10. That's where the hole occurs. Okay? So I hope that makes sense. I don't know if it's on the exam or not, but if it is. Okay. A lot of times I make the study guide a little bit harder, so you kind of will overstudy and get some of that information, and then maybe one of the hard questions won't be on the exam. Okay. Graph 1 over x. Okay, to do that, you can make like a little table of values, x and f of x, and think about what you can have. Well, you could have -1, you could have -2. I usually throw in -1/2, and then I do the positives, 1, 2, and 1/2, like that. Those are the points I usually use. You're not going to be able to put in 0 because you can't divide by 0. So we know that I'm going to put the asymptotes in red, so hopefully you can see them. There's an asymptote there and an asymptote there. And this is one of our basic functions that we did earlier. But anyway, when you plug in -1, you get -1. When you plug in -2, you get -1/2. When you plug in -1/2, you get -2. So we can graph those, -1, -1, -2, 1/2. It's really hard to draw on here, but you're going to get this little graph. I'll try to give you better graph paper on the test. Anyway, it kind of looks like that. And then you get a mirror image. It's symmetric about the origin, but you get 1, 1, 2, 1/2, and then 1/2, 2. So 1, 1, 2, 1/2, and then 1/2, 2. So it's going to be there. Okay, and you'll do a better job drawing than me. Okay, now use transformations to graph this. So you have to think about what does the 3 do? Think about all you know about transformations. It's going to move it 3 to the left. Remember, it's x minus that number, whatever they use. And then it's going to be up 1. So 1 up. So it's probably easiest to start with your asymptotes. Move it 3 to the left, 1, 2, 3. So your asymptote's now here, your vertical one. And your horizontal one's going to be up 1. So it looks like that. Then you can just graph. There's no stretch or shrink here. So you can just graph based on that. And it's going to have the same basic shape. And then you just have to shift them over. But you can go by your new kind of origin there because you moved the asymptotes. Anyway, that's the way it would look. So there you go. That was page 3.